sklearnpreprocessingLabelEncoder. Description: Explain in detail. LabelEncoder is a class in scikit-learn that transforms categorical features into numerical features. It assigns a unique integer to each category. This is particularly useful for machine learning algorithms that can only work with numerical data. Inputs. Input 1. Explain in detail a 1D array-like object containing categorical data. This can be a list, a NumPy array, or a pandas series. Input 2. Explain in detail none. Outputs. Output 1. Explain in detail a 1D array-like object containing the encoded numerical values corresponding to the original categorical data. Output 2. Explain in detail a dictionary mapping the original categorical labels to their assigned numerical codes. This dictionary is stored in the class's attribute of the LabelEncoder object. Steps. Step 1. Explain in detail. The LabelEncoder first fits itself to the input categorical data. This involves identifying the unique categories present in the data and assigning them unique integer codes. Step 2. Explain in detail. Once fitted, the LabelEncoder can then transform the input data by converting each categorical value into its corresponding numerical code. Metrics. Metric 1. Explain in detail none. Metric 2. Explain in detail none. Visualization plots. Visualization plot 1. Explain in detail none. Visualization plot 2. Explain in detail none. Fine-tune parameters. Parameter 1. Explain in detail none. Parameter 2. Explain in detail none. Uncertainty methods. Uncertainty method 1. Explain in detail none. Uncertainty method 2. Explain in detail none. Challenges and fixes. Challenge 1. Explain in detail data leakage. If the LabelEncoder is fitted on the entire dataset, including both training and test data, it may lead to data leakage. The encoder will learn the mapping between categories and codes based on the test data, potentially introducing information about the test set into the training process. This can result in an overly optimistic evaluation of the model's performance. Sample use case that resulted in challenge 1 using LabelEncoder on the entire dataset before splitting it into training and test sets. Fixes to challenge 1. Fit the LabelEncoder only on the training data, and then use the same fitted encoder to transform both the training and test data. This ensures that the encoder only learns the mapping from the training data, preventing data leakage. Challenge 2. Explain in detail handling new categories. If the LabelEncoder encounters a new category during the transformation process that was not present in the training data, it will raise an error. This can occur, for example, when dealing with real-world data where new categories might emerge over time. Sample use case that resulted in challenge 2 encountering a new category in the test data that was not seen during training. Fixes to challenge 2. To address this, you can either handle new categories by assigning them a new code, for example, by using a placeholder value, or by using a different encoding technique, such as one-hot encoder, that can handle unseen categories gracefully.